Now that we know how to conduct a hypothesis test for a paired data set by hand, we're going to make sure that we understand everything by looking at the same type of test, but this time with a computer output that's been doing a lot of the heavy calculations for us. So suppose researchers want to know whether the use of cell phones impairs reaction times in a driving skills test. So reaction times in milliseconds are measured when subjects perform the driving test without cell phones, sample 1, and then again with the same subjects using the cell phones, sample 2. Before observations were taken for these two conditions, subjects had a warm-up time interval to become familiar with the task, so reaction times would not tend to change from one condition to the other merely because of increased familiarity. The hypothesis test outputs for two computer programs are below. Use these results to answer the questions. Now in this particular example, I'm giving you both computer outputs, and that's because I don't want you to get confused by one output versus the other. Sometimes I will give you StatCrunch, and sometimes I will give you Minitab. So for the notes, we write them both down because that way we're familiar with both of them. Right, so the top one is StatCrunch, the bottom one is Minitab. And you can see I have a whole bunch of stuff highlighted in different colors because we're going to need it later on for other information. All right, so we're going to start off with, sorry, I realized I had a little too much revealed there and some of that stuff was blocked off for your notes, so now I've blocked it. Now the degrees of freedom, I left blank here, there it is, right? But you can see that n is equal to 32 if you look at the Minitab output. So we need to be able to figure out our degrees of freedom from n, but of course we know that degrees of freedom, is n minus 1. So that would make it so that it's 31. There, and I highlighted it in that aqua color, which matches the n and the empty degrees of freedom box. All right, now what was the average time when not using the cell phone? So when they didn't use the cell phone, how long did it take them to react? Well, that would be that red box right there, or excuse me, not the red box, the not using cell phone box right there. So 534.6 milliseconds, because they said everything was in milliseconds. MS, by the way, is the abbreviation for milliseconds. Now we're going to compute the standard error of the mean time when not using the cell phone. So you can see that you were given standard deviation right here. Standard deviation 66.4. And we want to compute the standard error, which is blocked off in the notes. But remember that standard error of an x bar is approximately s over the square root of n. So you just need to take 66.4 and divide it by the square root of n, which I have right here. And then I grabbed my calculator and I found it to be about 11.7. I'll prove that to you if I can get my calculator to work. 66.4 divided by the square root, so second square root of 32, it's 11.7. All right, that's done. All right, now what was the average time difference? Well, the difference is the one that I've got the red box around in both of them. See that sample difference right there? That's a negative 50.63 milliseconds. So that will be our answer for that one. And of course, the symbol for that is D bar, because average difference means, average difference means you're talking about the mean. And D bar is the mean of those differences, just like X bar is the sample mean. All right, so we have that. And let me give it a red box to match the highlighting we have up here. There we go. Now it matches the highlighting. So now we have to compute the standard deviation in the differences. So that's this part right here, standard deviation. Now you can see the standard error is 9.28, and you were given it right here in that yellow box for both of them, 9.28. But again, we know that the standard error is approximately the standard deviation for the differences divided by the square root of n, which in this case is the square root of 32. So let's see here. We know that SED bar is equal to approximately SD over the square root of n. So standard deviation of the differences divided by the square root of n. And we know that that's 9.28. Again, that's that yellow box part right there. Okay. All right, so then we need to multiply both sides by the square root of 32. So let me see if I can show this to you. So that means that 1 second. There, we know that the standard deviation for the differences is approximately equal to 9.28 times the square root of 32. That means the standard deviation for those differences is approximately 52.496. And again, that's just found with a calculator. 9.28 times the square root of 32. It's kind of the opposite of the problem we did earlier. So 52.496. And there we have that one. So these two problems, part C and part E, those are ones I kind of love to give on final exams because they're testing actually a chapter 8 concept. Do you understand how to use that formula from chapter 8 for the standard error? So this particular one, we knew the standard deviation was 66.4 and the n, and we just had to find the standard error, right? 11.7. And then for this other one, the more difficult one, we knew the standard error was 9.28 and we knew n was 32, and we had to multiply both sides by the square root of 32 in order to find the standard deviation, which we were looking for. So I love those kind of questions because they're one of the ways I can sneak chapter 8 into a test. All right, now it says in the problem it says, suppose researchers want to know whether the use of cell phones impairs reaction times. Impairs. So which hypotheses is that referring to? Circle one. Okay, so if we go back here, you can kind of see it right here in that kind of, I don't know, blue box right there. It says mu1 minus mu2 is less than 0 because we have not using cell phone minus using cell phone. And it tells us which one's group 1, that's the not using cell phone group, and then group 2 is the using cell phone group. So the computer output's telling us the group 1 is the not using cell phone group. And you can see less than 0 right there in StatCrunch. It's really easy. Minitab's a little harder to read. It's down at the very bottom. It says equal 0 for the difference versus less than 0. So it tells us that it's doing that kind of test where we have equal 0 versus less than 0. So that's a less than test. So we should circle the middle one here. If I can get my box up there. All right, so there's our result. Now we have to explain why this happens. Well, notice that the computer used not using cell phone as group 1. Right? Once they establish the not using cell phone group, here let me highlight it. The not using cell phone group is your group 1 group. So right there, that means that it's group 1 minus group 2 is how the difference is going to get worked. All right, so impaired, that word impaired in the original problem, which let me highlight it right here. That word means that we want to make it so that using the cell phone will be longer reaction times than not using. In other words, not using that cell phone will have a quicker reaction time, a smaller reaction time, right? So the not using cell group will be smaller than the using cell group. And that means when you subtract, right, as we say we're going to do group 1 minus group 2. We're going to subtract here. So when we subtract like that, it should be negative, i.e. less than 0. Right? Because you expect the using cell phone group, group 2, to be larger than the not using cell phone group. You expect the not using cell phone group to be smaller. I'm going to get rid of that color just to make it clearer. All right, so this not using cell phone group is smaller, and since the smaller one's in front, when you subtract, you should be negative. All right, now the computer outputs don't write the D part, but we do when we do it by hand. Well, that's okay. What they're doing is they're saying group 1 is the not using cell phone, group 2 is the using cell phone. And we want group 1 to be, the not using part, to be less than group 2. That's what impaired will mean. In other words, group 1 will be less than group 2. And that means, in particular, our alternative hypotheses will be written like this, right? The not using will be less than the using. Right? That means not using minus using will be less than 0. Now when we do it by hand, we go with this symbol right here. Mu d is less than 0. That's the by hand way of writing it. Computers can't do that. They don't know the difference between a dependent sample and an independent sample. So computers will write it more like this one in the middle. And that's okay. You just have to know the computer's going to write it that way, but we would write it this way for by hand work because it's a dependent sample. The dependent samples are the ones that get to use the D like that. Now, suppose we had gone the other direction. Suppose we had gone, oh, should have written one more comment. I'm so sorry. So just real quickly, they're the same hypotheses. They're just written differently. Right. When we're working with paired t-tests, however, we will always use mu d. We will not be using this other notation. Computers use this notation, but we do not. Not for a paired t-test. So for paired t-tests, we will always use mu d. And I better highlight that, the whole thing. When working with paired t-tests, we will always use mu d. All right, now back to what I was saying earlier. If we had reversed these and done sample 2 minus sample 1, what would that have done to the hypotheses? Well, if you'd done that, then you would have made group 1 using the cell phone, and group 2 would be not using the cell phone, right? Because you'd be reversing the order here, right? So it'd be sample 2 minus sample 1. Sorry, let me correct that. What we'll do is we'll leave the using cell phone group as group 2, and then we still want to know whether the using cell phone group is larger than the not using cell phone group, right? Oops, let me get rid of that extra tabbing there. Okay. All right, so what's that going to mean for our hypotheses? Well, it's going to cause it to reverse is what it's going to cause it to do. So it's going to go backwards. So it's going to be using in front and not using in back. So let me put that in there. And again, I'm not bothering with the null hypothesis because the null hypothesis is always equal to 0. It's kind of irrelevant. Right? What matters to us is the alternative here. So if you have using the cell phone in front as your first thing, right, then when you subtract not using, you expect not using to be smaller than using. You expect when people use their cell phones, it's going to take them longer to do things. So this number is expected to be bigger. So the bigger number minus the smaller number should be positive, should be greater than 0, which means that our alternative hypothesis will become mu d greater than 0. Right? So it reverses it. So when it was mu1 minus mu2, that's this one right here, it ended up being mu d less than 0, right? If you do sample 2 minus sample 1, then it causes it to be greater than 0. And that means the same note that we had from before will happen again. So the word impair doesn't necessarily imply a left-tailed or a right-tailed test. It all depends on who you put in front in your group. Sorry, before I go grab anything else, I just want to clarify. The change is right here. The old one had group 1 as the not using cell phone group right here. So group 1 is not using cell phone. Let me grab the green or something. And this one, because it does using cell in front, it's making it so that the using cell phone group is group 1. I should reverse that, sorry. So if the using cell phone group is group 1, that means that you want using to be greater than not using. You expect using to take more time. And that means you're reversing your process. What used to be a left-tailed test up here is going to become a right-tailed test down here. And that means mu d would be greater than 0 if you establish group 2, the using cell phone group to be group 1, the group in front. So it sounds a little more confusing than it is. It all depends on which is the group 1. Whatever group is put in front, that's your group 1. So if group 1 was the not using cell group, then it'll be a less than test. If group 1 is the using cell group, it'll be a greater than test. And that reiterates the same note we had before, that in Chapter 11, words like impaired will not always mean a left-tailed test or a right-tailed test. It all depends on the setup of group 1 and group 2. You have to pay close attention to who's group 1, who's group 2, and figure out whether it's a left-tailed or right-tailed test from there. And we'll pause right there and we'll pick back up and finish this problem in the next video.